Hello, welcome back to 3 Delirium. My name is AJ, and today we're going to talk about something a little bit different. So, after a video that I posted a few weeks ago of the paint rack assembly, actually, I touched on a big issue that comes up in 3D printing a lot when I had a large mass of messy extrusion that just kind of formed a big ball of what some people call spaghetti. And I showed a picture of it, but I didn't really explain what it was, how it happened, or what I'm going to do differently after experiencing that. Well, as it turns out, it's actually happened again. And so I figured this is a great opportunity to touch on this, why it's a problem, more so than just wasting filament, unless I wanted some sort of Easter basket filler, and some of the other important issues that are all kind of solved with one single solution. Well, stay tuned and I'll show you what I'm talking about. So here is a breakdown of the basics of what we're working with. This bottom line here represents the build plate, and this brassy looking part at the top would be the nozzle that the filament will come out of, and above that would be the heatsink. As the print head moves around and lets out filament, it creates lines. There's lines everywhere, all over the object, all over the build plate, all over the surface, and all of these lines all connect together to form a layer. And the basics of 3D printing are just a layer on layer on layer, building up and up and up. But this all comes down to the biggest and most important part is each layer relies on the previous layer being what the computer expects. The 3D printer cannot actually see what's going on, so it will just keep going, expecting when it lays a layer down, it assumes the previous layer was correct as well. So even when the first layer goes down, it assumes that the build plate is level due to the probing and testing that it does in the beginning. So after you put layer upon layer down, one of the first issues that you might run into is what's called thermal expansion or thermal contraction. Just like an ice cube in the freezer, the water swells when it turns into ice, so does the plastic. So it starts as this liquid in one place. It will expand and contract depending on how warm or cold different parts are. The bed is heated so that it helps to hold, but that does mean on larger prints that some places might be at a heated spot while other places might be higher up, further away from the heat, and therefore expanding or contracting in a different way. So if the object isn't sticking tight to the base, it can start to pull up in places where, like I mentioned before, there is a lack of adhesion or a lack of glue stick, to be precise. So when it starts to pull up in a way, it may be in just one corner, and that would be probably the first and biggest issue that will then lead to compounding other issues. So thermal expansion and thermal contraction, it has happened many times already, and has actually happened on this series already. So if we go back to the videos that had PETG versus PLA, we have the two buddies that I made. This buddy was the first test print that I made with my printer back when I first got it, and I made this PETG version just to test the differences between the two. But I don't know if any viewers at home might have noticed, this guy wasn't actually flat. His front paws lifted up from the plate when I first printed him, it doesn't really make much of a difference for this adorable little guy to just sit and look good on the shelf. But if it comes down to some practical print, it would definitely cause a lot of issues. But he does rock back and forth and kind of wobbles whenever you let him go. The same thing happened to me when making these board game pieces as well. You can kind of see there's a little bit of a difference in the height. They're both meant to be exactly the same shape. One just has a hole in it. But there is a little bit of a gap there where this one had a bit of corner lift and the other one did not. And this is even further shown with the actual board for those game pieces itself. So when it finally worked, it was nice and flat. But midway through printing, I did encounter this. So I noticed that the one side had really started to lift up, so I knew I needed to terminate that print to avoid wasting any more filament. I couldn't tell you why I kept this, but I guess it turns out that I'm glad I did. I guess I've used it a few times as like a cutting mat or something like that for my hobby desk here, but whenever I printed it again, I made sure there was plenty of glue stick on the build plate. So the next severe issue comes from actually based on this one. So sometimes the print will just so happen to correct itself, but usually it does not. So when sometimes the corner will pull up on the bottom, and the higher and higher it prints, just the less of an impact it makes. Kind of like the princess and the pea, it can make a little bit of a difference, but sometimes it also kind of lifts away. And then you're left with an edge that is higher than the 3D printer expects. So as the print head is moving around and getting ready to come back for the next pass, sometimes it can just catch on that lip and lift right away. Just lift the whole thing up, or a section, or move a part out of the way, and then suddenly there's nothing underneath it and it'll still keep printing anyway. So this is still an issue coming from thermal expansion and contraction, like I just mentioned. And it is ironic that this little baby dragon is here to demonstrate exactly what I mean. Because the file itself from Thingiverse, as I've mentioned before, came with built-on supports. Now, I could tell that it's most likely for a resin printer, the kind of supports that come with this. But I figured it might be okay anyway, and it turns out that it wasn't. So this is a support that was in the back. And if I bring this up here, you can kind of see that it did start to print all the spaghetti and got kind of messed up. So this was in the back. The print head would have knocked it out of the way and still attempted to print on top of it. Now it just so happened that it seemed to only affect this built-on support material and didn't actually affect the rest of the model. But this is extremely lucky of this situation. If I've encountered this problem before, it's never gone this well. The next issue that this can lead to, as well as other causes, can lead to what's known as layer shift. So as the model builds from the bottom up, maybe the desk is bumped, or you have a little bit of this thermal expansion like I mentioned before, and it knocks the model out of the way. But then still kind of starts to recover, but everything from that moment on is shifted ever so slightly, but finishes normally anyway. So you'll have a shift in the entire model that is very noticeable, and if you're lucky, it finishes. If you're not lucky, it will make a big mess, like the spaghetti. I've mentioned models from the internet before, from Thingiverse, and more particular from a creator known as That Evil One. Here are some tanks that I tried to print from the same creator, and I had right near the final quarter, I experienced a layer shift right through here. I remember specifically when this happened because as a new 3D printer owner, I was very curious, and this was stuck to the build plate. The infill had a very enticing looking wavy pattern, I believe is called a gyroid, and I just wanted to see what it felt like. So I remember poking it while it also tried to move towards me. So I ended up pushing the entire model even a centimeter, millimeter, and it was enough to cause this entire shift. You can see it right there, right through here. It kind of affected the entire thing. I was lucky that it was able to still finish. If it shifted too far, then it would start printing on midair. And finally, like I keep mentioning, it is impossible for the printer to print over nothing. So if it shifts out of the way or thermal expands and pushes the whole entire model out of the way, you'll end up with this. This is what leads to the spaghetti. This is also one of the benefits of this kind of build plate as well. So this is just made of steel, and on this plate here, on the heating surface, there are magnets. So it just magnets shut and it holds nice and steady. But with a removable flexi print surface, I can merely flex this and it should come off easily. But there is still, kind of see in the shimmer of the light, there is still glue stick that I had to use, plenty of it as well, to make sure that each of these little individual footprints, ironic, the footprint of the model was big enough to hold. If you have a teeny tiny footprint, it'll be a lot more difficult to stick to the plate. A nice big wide footprint, and it'll hold a lot easier. This has been a fantastic opportunity for a teachable moment coming from one of my mistakes. Like I said before, this is very easy to avoid if I just have a good keen eye on my machine. If I just hit print and walk away, assuming that if I come back in 3 hours when it's done, it leads to this. So, plenty of glue stick at the beginning, diligently watching it, and keeping the room sometimes even warm enough to have the filament prepared for the machine as well. All of these things kind of add together to avoid this. Maybe I will keep this for Easter of next year. This would make fantastic Easter basket filler. What if I can hide it somewhere in my wife's sewing kit? Thanks for joining me here at 3 Delirium, where we can all hallucinate about the possibilities of 3D printing. I'll see you next time.